All right, here's properties of logarithms. So um, we have product rule, quotient rule, and power rule. So just a small recap. For product rule, if you guys have a logarithm with a base and then in the argument you have m times n, you can split it up so that it's um, two separate logarithms that are the same, and then you're just adding them together. That's the product rule. Quotient rule is if you have a logarithm and its base, and the argument is m divided by n, then what you're really doing is subtracting log of base m minus log of base n. And then for power rule, notice that our argument has a power of n. So what basically the power rule means is you can put the power in front of the logarithm, just like that. Or all these you guys can go in reverse. If you guys see the plus, then you can go back to this form. And if you have this, then you can go back into this form. So in this homework, you guys are going to use a lot of these rules to either expand or to condense. All right, so let's look at number 1. All right, so notice that the two logarithms and its base are the same. And since you guys have a plus, this means you guys are going to use product rule. So we're going to have log base 7, and remember it says to condense, right? So that means you're going to multiply 9 times 4. And this is going to give you guys log base 7 of 36. And now we can simplify. So when you guys simplify, well, I know that 7, this can't be a base of 7. So we're going to use our change of base formula, which is log of 36 over log of 7. Put this into your guys' calculator. And we should get about 1.84. Alright, so that's number 1. Alright, number 2. So they have the same log and base. That's good. And look, there's a subtraction sign in between. So that means we're going to go doing the quotient rule. So log base 2. Now when you guys condense it, when it's subtraction, it's this one divided by that one. So 80 divided by 5, log base 2 of 80 divided by 5, which is 16. And now from here, you guys, I noticed that this 2 and that 16, you can get a common base of 2. So I'm going to set this equal to x, and I'm going to use our exponent rule. So 2 to the x power is equal to 16. 2 to the x is equal to, change 16 to be a base of 2, so 2 to the 4th. X is going to equal to 4. Okay. Alright, number 3. This is a power rule because I'm noticing that we have something in front of the logarithm, and if you have something in front of the log, you can make that into a power. So log base 3 of 81 to the 1/2 power. Now, 1/2 power, you guys. Log base 3. 1/2 power is a square root, so really you're taking the square root of 81. And the square root of 81, you guys, is 9. And now I'm going to change this to exponential because I can see both of these could be a base of 3. So equals x. 3 to the x power is equal to 9. 3 to the x is equal to 3 to the second power. X is equal to 2. Alright, so this is a combination, okay? So first, notice you guys that when you guys do these rules, notice that there's nothing in front of the logarithms, right? It's just a log and a log. So for these, we have to make these powers first. So we're going to get log base 4 of 8 to the third minus log base 4 of 2 to the fifth. Now we'll simplify that. Log base 4 of 8 to the third power is 512 minus log base 4 of 32. Now, see, there's nothing in front of the logarithms, right? And we have subtraction. So now we can use division. So log base 4 using quotient rule of 512 divided by 32. And this is going to give us log base 4 of 16. And right over here. And I'm noticing that the 4 and 16 have a common base of 4, so I'm going to set this equal to x. 4 to the x is equal to 16. 4 to the x is equal to 4 to the second. X is equal to 2. Okay, over here. Alright, so change this so that these are not there anymore. So using power rule, so we're going to have log base 5 of x to the 7th power plus log base 5 of y to the 12th. Notice that when I put this over here, it's 3 times 4. Okay, so now we just have logs and a plus sign in between, so that means we can multiply them. So log base 5 of x to the 7th, y to the 12th. And that's as much as you guys can simplify. Alright, 6. Okay, so this is a combination of stuff, so let's work on the parentheses first. So let's get this to be over there. So log base 3 of a to the 7th plus log base 3 a to the 4th minus log base 3 of b to the 2nd. So now let's work with the parentheses and see we have log and there's a minus sign, so that means we can use quotient rule. Log base 3 of a to the 7th plus log base 3 of a to the 4th divided by b squared. Now we have log and there's a positive sign, so now we can multiply it. So log base 3 of a to the 7th times a to the 4th over b to the 2nd. And this simply, you guys, turns into log base 3 of a to the 11th over b squared. Okay. 7. Alright, so first let's just have all logs, right? So I'm going to make that 4 go to the top. So log base 4, x to the 7th, minus log base 4, x squared. This 4 is going to go there using power rule, so plus log base 4 of x to the 12th. Now, let's just go from left to right. So let's do these two. So we're going to have log base 4, since it's subtraction, you guys are going to be doing quotient rule. So x to the 7th over x squared plus log base 4 of x to the 12th. I could simplify that, you guys, so that's going to be log base 4 of x to the 5th plus log base 4 of x to the 12th. Log, positive, so now we can use the product rule. So log base 4 of x to the 5th times x to the 12th. And you guys know when you have two things being multiplied together with common bases, then you just add the exponent. So x to the 17th. And there you guys go. Alright, this one. So this one, let's distribute this 1/2 to both of these, okay? Or, sorry, let's work in the parentheses, so let's do this. So, log, minus sign, so quotient rule. So, 1/2, and we're going to get log base 6 of 45 divided by 5, plus log base 6 of 12. So we're going to get 1/2 log base 6 of 9 plus log base 6 of 12. Now, let's move this power over there because, right, we usually always like logs by themselves. So log base 6 of 9, this is your power rule, to the 1/2 plus log base 6 of 12. Now remember, you guys, 9 to the 1/2 is square root of 9. So what we really have is log base 6 of 3 plus log base 6 of 12. So now we have log, another positive in between, so log base 6, this is our product rule, 3 times 12. Log base 6 of 36, and since we have both the 6 and 36 to be common bases of 6, we can now make a exponential form. 60x is equal to 6 squared, x is equal to 2. Alright, so for this one, so we're going to condense it, and then we are going to be using the change of base formula. So, log minus, so quotient rule, so log base 9 of 35 divided by 7, log base 9 of 5, and now let's use change of base formula, so we're going to get log of 5 over log of 9. And this is going to be roughly around log of 5 divided by log of 9. 0.73. 10. Okay, so remember, we always want the logs to be by themselves, right? That's the only thing that should be in the front. So these two need to go on top using power rule. So log base 3 of 8 to the 2nd power minus log base 3 of 2 to the 4th power. So log base 3 of 64 minus log base 3 of 16. Okay, so now log minus sign, so log base 3 of 64 divided by 16. Log base 3 of 4. Now we're going to use change of base formula, so log of 4 over log of 3. This simplifies to log of 4 divided by log of 3. 1.26. Alright. Okay, this one. So remember we want logs to be in the front, so this we're going to make it to a power. Log base 4 of 8 to the 1/3 power plus log base 4 of 15. Now remember 1/3, you guys, is a cube root. So the cube root of 8 is log base 4 of 2 plus log base 4 of 15. Log, positive sign, so that means product rule. So log base 4, 2 times 15. Log base 4 of 30. We're going to change this to be, change the base formula now. So log of 30 over log of 4. Which is log 30 divided by log 4, 2.45. Okay, number 12. So remember, let's get all these to be logs in front. So let's move this 2 to over there to be the power rule. So log of 2 of 27 plus log of 2 of 4 minus log of 2 of 3 to the second. So we have log of 2 of 27 plus log of 2 of 4 minus log of 2 of 9. Let's just go from left to right. So log and a positive, so that's going to be product rule. So log base 2 of 27 times 4 minus log of 2 of 9. Log of 2 of 108 minus log of 2 of 9. Log and a minus sign, so that's going to be quotient rule. So log of base 2, 108 divided by 9. 108 divided by 9. Log of 2 is going to be 12. Now we're going to do change of base formula, so log of 12 over log of 2. And that's roughly going to be log of 12 divided by log of 2. 3.58. Alright, last 6. Okay, we're going to expand. So when we expand, you guys, we basically have to have a bunch of logs, pretty much, right? So since m and n, there's multiplication in between there. So log, this is product rule, base 8 of m plus log base 8 of n squared. And now this power, we can put it to the front now. So log base 8 of m plus 2 log base 8 of n. That's what expansion looks like. Okay, 14. So we have division in the argument, so that means it's going to be quotient rule. So log of x to the 9th minus log of y to the 4th. Now let's bring both of our powers down using our power rule. So 9 log of x minus 4 log of y. Alright, 15. Okay, so for this one, there's a couple things we could do, but for the sake of argument, let's just move this 3 to go on the front. Actually, let's just distribute the 3 to go in. So, gonna multiply those inside. So, log base 2 of a to the 15th and b to the 6th. Now, from here, a to the 15th times b to the 6th, that's the product rule. So log base 2 of a to the 15th plus log base 2 of b to the 6th. And then let's move both of these to go in the front. So then we're going to get 15 log base 2 of a plus 6 log base 2 of b. Let's distribute the second power to both. So log of p to the 8 over q to the 14th. And now we have quotient rule because there's division in the argument. So log of p to the 8 minus log of q to the 14th. Now let's use power rules and bring both of the powers to the front of the log. So 8 log of p minus 14 log of q. Alright, this one, so we have the square root, so that's going to be a 1/2 power, so log base 5 of a to the 7th, b to the 1/2. And now let's just distribute that, so log base 5 of a to the 7 over 2 and b to the 1/2. Now, since there's multiplication, that's the product rule, so log base 5 of a to the 7/2 plus log base 5 of b to the 1/2. And now let's just bring the powers to the front using power rule, so 7 over 2 log base 5 of a plus 1/2 log base 5 of b. And our last problem, so let's get log base 4 and make that cube root into a power. So c to the 2nd, d to the 15th to the 1/3 power. Let's distribute that 1/3 to both powers. So log base 4 of c to the 2/3, d to the 15 over 3, you guys, is 5. And now this is multiplication, so we can use the product rule, log base 4 of c to the 2/3 plus log base 4 of d to the 5th. Let's bring both powers to the front using power rule, so 2/3 log base 4 of c plus 5 log base 4 of d. And that's pretty much your guys' homework, okay?